go, oh, to the right is positive, the net force is 1 Newton. It is the exact same math as we just did over there, just a different context. Before I was talking about walking, now we're just talking about forces. They're both vectors involved. This is chapter 2 context. That's chapter 3. Yes?
I just can't see. That's F. What?
Where are you looking?
Yeah, what did you say? I can't see.
Here?
Yeah,
That's an F with a vector symbol over it.
okay.
Net under as a subscript, so it's the net force equals 1 Newton.
Okay.
So, is it just that section of the board that you're having difficulty seeing?
Yeah, I just couldn't see it, yeah.
Okay. That dramatic pause I did just then was to see if there were any other questions. You don't have to wait for me to ask you if you had questions. All right, I know what you're thinking. You're going, that tape is great. I understand it all perfectly. Let's make it more complicated. All right, let's do it. In some sense, what I'm about to do is easier. You know what? Let's write a little bit less. So we have an object that's moving, it's going to go 3 meters to the right and then 2 meters up. What I'm asking you is, what is the displacement? Again, chapter 3 vocabulary, we'll use it anyway. I'm going to write total up above it in parentheses. When I ask for the displacement, it should be understood in this context, although not necessarily within the first hour of class, but at some point it should be understood when I'm asking for the displacement, I'm asking for the total, or overall. The symbol is a delta with an X. That's a capital delta, X, and put the vector symbol over the X. And I've mentioned it before, but that is a vector symbol. I probably should take a moment to talk about the other vector symbols. So let's first draw a picture. We're starting someplace. I'm going to go 3 meters to the right. We're going to pretend that's 3 meters. Then I go 2 meters up. There's the simple answer. And then there's the more complex one that requires the use of a calculator given the numbers I have here. So we start with the calculator one or without the calculator one?
Without.
All right, so it's a two-dimensional problem. So I can't get away with just a plus minus. But I am going to bring in my unit vectors. I'm going to say to the right is my I hat, and then up is j hat. So I just write that off to the side. I'm defining my directions. I hat's this way, j hat's that way. If you want I hat up and j hat the other way, sure, why not? But I've defined it this way. And so instead of saying right, I'm going to use I hat. So this is 3 meters I hat plus, because I'm adding them, 2 meters j hat. And so my answer is 3 meters I hat plus 2 meters j hat. Done. Answer. By the way, this is known as rectangular form. If I don't specify, that's fine. All right. And you're thinking, hey, that was easy. How about the calculator one? Challenge me some. All right, let's do it. Any questions before we do the calculator version? Jasmine.
Jasmira.
Oh,
It's okay.
Jasmira, I apologize.
It's okay.
Jasmira.
So the answer was, we supposed to put the delta above it, or,
In front.
confused on that? Okay, so that would go above the answer. Like, we'll write the answer out, and then we'll put the delta above it?
No, you would, as far as the answer, you would just write that.
I'll just write that.
Yeah, and the symbol for this whole thing is display, I'm just saying displacement is that.
Okay.
So that first part means displacement.
Say it again?
So that first part means displacement, the triangle, the x and the.
Yeah, that whole, this whole bit right here, I will circle it, this whole thing here means displacement. I'm hoping it will make a little bit more sense when we get there in chapter 3. This is just sort of a teaser of what's to come. Why is there a delta there? I don't know. Perhaps I will tune in later. Jasmine, I hope it's not stuck now. Jasmira, did I answer your question?
Yeah, sort of,
Oh.
but if you keep going, I'll get the feel of it.
All right. Yeah, if at any point, dude, you want to re-ask the same question, just go for it.
Okay.
All right, so now the calculator version. Now, when I'm expressing a vector, again, there's two things. Actually, you tell me, what are the two things all vectors have?
Direction.
Yep, those are the two things right there. So another way of finding out what that vector is where am I relative to where I started? In other words, what is that distance there? And what is the direction? God. One of these. Because that definitely has a direction, and it definitely has a magnitude or size. Well, first off, right and up are perpendicular to each other. This is a right triangle. For some of you, dusting off the cobwebs, or others of you, more recent, how would we find the length of this?
A squared plus b squared equals c squared.
Otherwise known as?
Pythagorean.
I'm hoping people are familiar enough with Pythagorean theorem. I'm looking for the scared eyes as opposed to everyone nodding. I'm not seeing scared, that's good. Or bad if it's blatant and I'm just missing it. If you have a right triangle, in other words, any triangle with a right angle in it, besides A, B, and C, a squared plus b squared is equal to c squared. So if I label this, let's just say C for right now. 2 squared plus 3 squared is equal to c squared. 4 plus 9 is equal to c. 13 is equal to, c squared. 13 equals c squared, therefore c is the square root of 13, which is something absolutely spectacular that will change your world. 3 point something. It is helpful if people have, a couple of people have calculators, because there are oftentimes I'm gonna go and the answer is, and then wait for someone to actually use a calculator.
It is 3.6.
3.6,
There's more numbers after, but that's rounding it.
okay? So, what is the distance a person is, or let's get the wording right, how far, after going 3 meters right and 2 meters up, how far is this object away from its starting point?
3.6 meters?
There we go. And that last bit I did was, so I wanted to hear some units. Mathematically, 3.6, spot on, I assume. So 3.6 meters. I'm circling it like that's really the whole thing. That's the magnitude of my answer. What's the direction? How do you figure out what that direction is? How do you communicate that?
K-hat?
Pardon?
K-hat?
No, well, I've had students who try to pull that one off. There's the hard answer, which I'm gonna start out with, and then I'm gonna talk about the easy way. Or at least the easy solution to it. What you really should be using here is trig. Now, how many people in here have done trig before? Half. Okay. It's okay, trig is not required at all. So, I would not ask you to actually find that direction. I want you to acknowledge that there is a direction here. So, the wording of the question would have to be something like, how many meters is it away, or how far is it away from where it started? Something like that, where you don't actually have to find the direction this way. And for that 1/2 of having done trig, I'm gonna do a 15-second aside. Trig is definitely not in scope for the course, so you don't need to worry about it, but this is just for the benefit of, the worldwide fan base and the person who's had a little bit of trig, or someone who's about to be taking trig. The label that as theta. The tangent of theta is the opposite of the adjacent. So theta is the arctan of 2/3. All right, enough of the aside. If all of that is gibberish to you, it's okay. If I said SOHCAHTOA, does that ring more bells? I got a couple more nods on that one. Yeah, that's all this is. This is SOHCAHTOA. Questions to hear? Ariana?
What's the other way to do that? That's not including trig. You said there are 2 ways.
Yeah, no, the second way is use trig. Yeah,
Well,
the hard way is the fact that you have to use trig. The easy way is, I'm not gonna ask you to find the direction in that case. Just for completeness though. I guess you have a calculator. Could you do it's a TI something?
Yeah, 84.
So yours would probably have 10 with a -1 there of 2/3. So
10 is a -1.
there should be a 10 with a -1
Mm-hmm.
symbol on there.
You would like me to do the 2/3. 0.588, and then there's more. That's right.
0.588.
Mhm.
Are you in radians?
What?
Are you using, I think your calculator's in radians.
Would you like to use the calculator?
It's always awkward when I use these, let's see. 10 inverse 2. This one is too. Radians, that's a different unit system. 33.69 degrees. So the answer is, if I wanted the full thing, rectangular form, or 3.6 meters and 33.69 degrees. This is known as polar form. And some of the stuff that we've just gone over out of scope, again, the trig part, not part of the class. Just bonus information.
Yay.
So later on in the class, when someone says, who's done trig, go, yeah, I've been there. when I taught elementary school, I had, second, third, and fourth graders, I talked a little bit about vectors. I said, I'm only doing this just so that later on, when you're in high school or college, and so someone asks, have you done vectors? Go, elementary school. All right, class officially ended, 9 or 10 minutes ago. How far off is that? Only a minute off. So we will transition, take a break, stretch legs, say 10 minutes, and then we'll reconvene right here.